let's get started. Well, if I go back to the book, I've been sort of thinking, yeah, I need to go to rational powers. Now, if we go to rational powers, we can make sense of things. Well, on the try it problem, right before I move on, see if you get -6 here. And this should be 3 times the 4th root of 16 when you divide these. So it's 3 times 2, and that's 6. See if you get -6 here, +6 here. This one's kind of tough. The cube root, a clean cube root would be 1,000. You want clean, not square roots, but clean cube roots, right? And that would be 1,000 here, because the cube root of 1,000 is 10. And right here, that's kind of tough. What are we left over with, though? Now, keep in mind, 9 stays in, because 9 is a pretty square, but it's not a pretty cube, right? 9 can't come out. So 9 times 1,000, 1,000 comes out as 10. 6 times 10 is 60. So it's 60 times cube root of 9 plus, I'm willing to bet this is 9 that stays in. 9 times, it looks like 64. The 64 is a double dual, kind of. It has a pretty cube root, too. That's rare. The cube root of 64 is 4. 7 times 4 is 28. So that's 28 cube root of 9. So we get 60 cube root 9 plus 28 cube root 9. That would be 88 times cube root 9. Okay. But let's move on to rational exponents. So we define a to the 1 over n power to be the nth root of a. And we define a to the m over n power one or two ways. It could be the nth power of the nth root of a. The denominator is the root, as usual. Or it could be the nth root of the a to the m power. Either way you want to cut it. So rational exponents, we either get this or we get this. And they give you the way to do it verbally here. So, but example 11, you could do this one or two ways. Now, one way is more efficient, right? Sometimes one way would be more efficient, and sometimes it'd be the other way, We gave both ways for a reason. Sometimes this would be better, sometimes this would be better, but they're both the same incognito. Sometimes one's more easier to deal with. Like here, the cube root of 343 is, if we do it first, we get 7, and 7 squared is 49. That's more efficient. You could go the other way. This way, if you do the cube root of 343 squared, that's kind of yucky. That will give you 49. Yeah, we got 49 this way. We'll get 49 this way as well, but it's kind of yucky, right? It's better to do it this way this time around. 49 either way you cut it. Now, here, notice 9, you could do 9 at the 5th power first and then get the square root afterwards, but that's kind of yucky. Let's do the square root first. That's 3. 3 to the 5th power, that's better. That's not as yucky. 3 to the 5th power is 3 times itself 5 times in a row. That's 243. See if you get that. Moving along to example 12 now. Now, 4 divided by the 7th root of a squared. N as in Nebraska would be 7. M as in Michigan would be 2. So, but it's on the bottom. So we get 4 over a to the 2/7 power here where my cursor is. But remember how to handle that? You put a negative. You could either put the negative to the side, upstairs or downstairs. Negative is flexible. It's one of the few things it is. So we get 4 times a to the power of, it's just the a that's been powered, not the 4. So we get 4 times a to the power of negative 2/7. Now for the try it, well, remember, that 9, we chunked this up. That's and look on the inside here. On the inside here, what do we have? The ninth power of 5y. I would bust this up. You could do it this way. I'd do it the way we did it last video. Do 5y parentheses to the eighth times 5y parentheses to the understood 1, which that's really understood. So the 5y to the eighth comes out as 5y squared. Let's just do it. That's a lot. So what do we got? Insert equation x, sqrt, and the trick, that 5y to the ninth, write it as 5y to the eighth times 5y to the 1's understood. But now what's going to happen is that 5y to the eighth is going to come out as 5y to the, now be careful, that fourth power like that, right? No. Yeah. Actually, yes. Yes, indeed. And now that 5y other to the 1 just stays in. And since it's the 1 power, we can just not do the parentheses. That's only good because it's the 1 power. Well, remember the law of exponents that we've done before. That's x times 5 to the 4th by the bust-up rule times y to the 4th, again, the bust-up rule. And then, well, we got our square root of 5y that's just kind of dangling here. And, well, what do we have? So 5 to the 4th is 625. X is just there to the 1 power, understood. Now y to the 4th, and then sqrt of 5y just sticks. Yeah, that was a lot to have to verbalize, right? So there it is. We had to use some rules from videos ago, right? Probably 6 videos or 7 videos ago. Now this was just from 1 or 2 videos ago. We just made the 9, well, we want it to be divisible by the understood 2 index for the square root. If that were a cube root, be careful, the 9 would have been pretty, right? Just case in point, we're done with this one. And, that one, well, this one was kind of hard. We had to do all that. But if that would have been a cube root, life would have been easy. We would have had x times, I wish I could find my root symbol. That's kind of getting on my nerves. Insert equation. I'm having to go to the darn draw board every time. Insert equation. And, yeah, this ink equation gets on my nerves sometimes, but I won't mess it up, try not to get all screwy with it. So that's the cube root symbol. Who are we doing? And let's say I do the cube root of, well, let me put a parentheses in there. 5. No, it's interpreting that as a darn L. Erase it. No. Yeah, I don't think it can handle. Let's just exit drawing and zoom out. Let me just hit erase. Oh, here's the eraser. Okay, so there's erase. Here's right. And let me hit erase. It didn't like my parentheses so well. So let me write. So here's the cube root. This is not splendid. So here's the cube root of, I want parentheses, please, 5y cubed, or no, to the 9th. But I don't have a pen on this thing. That's a screwball interpretation of what I had written. 9th. Okay. And, okay, so, and I meant cube root up there. Oh, no. I screwed that up. But anyway, Yeah, it just screwed everything up. Insert equation and ink equation. I don't think this thing's too good. Cube root. This thing is awful. This thing stinks. Cube root. Okay, that's good. Just get it in there. No, forget it. But anyway, guys, if we wanted to do the cube root of 5y, that would be 5y. I'm about to raise to the power of, we want to do the cube root of 5y to the 9th. That would be the same thing as 5y to the 9th raised to the power of, we take the whole thing and we'd raise it to the power of 1/3. And that would be x times 5y cubed. Now, this is different from the trie problem, okay? So don't go getting excited on me. We've already done the trie problem up here. This is a different one. I'm doing the cube root now, which I'm having to write as 1/3 power because Microsoft won't work. So it's x cubed times 5 cubed times y cubed. And that's going to be, now let's do commutativity. That's 125 for 5 cubed times x times y cubed, maybe a little associativity too. But there's that. And notice there's no radical left over because the cube root cuts 9 clean. It cuts 9 down to a 3. So we pretty much cut this down to 5y cubed, didn't we? Right here on the second step right here. No further than. But that pencil editor just sucked up all my time. Yeah, that's awful. I hate that pencil editor. Let me try to make the most of what time I got left. Like if you want to simplify part A right here, I've got 2.5 minutes. But now 5 times 2 times the coefficient 3, all the coefficients. 5 times 2 times 3 right here, that's 30. And now we got x to the 3/4 times x to the 1/5. But remember from the laws of exponents that we've already done, we add the 3/4 and 1/5 up there in the exponent, and you do least common denominator. And it turns out, do the math, you'll get 19/20ths with the LCD math, least common denominator. Now for part B as in Bobby here, I'll go to it real quick. Now remember the half power would have been the square root, but the negative indicates reciprocal. So we do the reciprocal square root. We do the square root of the reciprocal, which is the square root of 9/16. And that, remember by the rules, that's square root 9 over square root 16. That's 3/4 right there. Yeah, I don't want to do the trie problem because, well, I could try to maybe get halfway there. That's a cube root of 8, which is 2. Now that's a cube root of x, which just is what it is. So 2 is free and liberated. Now the x is inside a cube root symbol, but you could just leave it to the 1/3 power. Either way, so it's 2 liberated, just 2 to the 1 power, or 2, times x to the 1/3. So 2 times 14 is 28. So we got 28 coefficient times x to the power of, well, the sum of 1/3 and 6/5, whatever that is. That's going to be our power of x. Let's see, that would be 5 plus 18, that would be 23 over 15. That would be the power. So we got 23 over the x to the power of 23 over 15. So our final answer would be 28. 2 times 14 is 28. X to the power of 23/15. See if you get that. And that's finally the end of radicals. But yeah, that's tough. But yeah. Now here, 15 just stays put. We got 15 times the 4th root of 25, and you can't really clean that up anymore, right? Anyway, that's good, or at least that's good enough for this problem. 15 times the 4th. I'll say more about some stuff we can do later. But 15 times the 4th root of 25. Have a good day. Bye-bye.